Go.
Hello.
Hello, Mr. Aaron, Mr. Ryan. How are you today? Good?
Good.
Do you still remember a few weeks ago we talked about permutation?
Yeah.
Yeah, like 1, 2, 3. The permutation.
Six. It was about
6 times,
2
yeah.
days ago.
Yeah, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and what's next? What's the last one?
3, 2, 1.
Well done. So that's permutation.
It's
Permutation.
been 30 seconds.
That's okay. Permutation is with orders, yes? Do you get it?
Yeah.
So these are order. And how about I tell you combination?
Combination.
Remember, this
It
is
looks like we don't need cash.
no, this is without orders, yeah? If I tell you pick 2 apples out of 3, how many ways can you pick? You just pick 2.
3.
It doesn't, yeah, 3 times. But if you permulate 2 apples out of 3, how many?
2.
No? So look, you said 3 kinds of ways to pick 2 apples out of 3, right? When you pick 2 apples, there's three kinds of way. When you pick it, after you finish picking, then for each one you have 2 orders, right? 3 times 2, so there are 6, right? Got it? Yeah?
Yeah.
So remember this permutation thing. How are we doing it? We talk about the recursive, the permutation algorithm, right? So basically we have 1, 2, and every time we swap with this element with any of these element, yeah, and we swap it, right? And then we continue. Remember, yeah?
Yeah.
Okay, so today we talk about combination. Okay, so look, if I have n items, and I want to pick k items, how many solutions do we have? Remember this notation, C? Yeah? C n k. This means to pick k items out of n, right? Yeah? Alright? So remember this P n k. Pick k items out of n, but with orders. This is without orders, yeah? Alright?
Yeah.
So this is equals what? P n k, right? Divided by what? This is with orders, this is without orders. So I have to divide it by
2.
by what? I have k.
C N K.
Look k what? Look, I have how many ways of k items with orders, k permutations with orders. If there are k numbers, how many solutions do we have when we permutate k?
K factorial.
Okay, yeah, k factorial. That's very well done. So this is with orders. This is without orders. So what do we need to divide here?
K.
K what? K what?
Factorial.
Yes. Look, do you get it? Yeah, we picking this. We can do it the other way. Look, first of all, we pick k items, but we don't care about orders, right? Yes? And how many orders for k items? K factorial, yeah? And then you times it. So you can do it this way. P n k equals k factorial times c n k, right? It's the same thing, yeah? Yeah? So P n k equals what? P n k equals n factorial divided by n minus k factorial. Okay? This is the formula. Okay? So Cnk equals what? N factorial divided by k factorial and n minus k factorial. Am I right? Yes? Does it make sense?
Yeah.
Okay, so now, today, if I tell you picking 2 numbers out of 3, C32, yeah? You need to tell me you need to return it C1, 2, 1, 3, 2, 3, and what else? I think that's it, right? Yeah? Eric, look. C32, picking 2 apples out of 3 apples. How many solutions do we have?
3.
Yeah. Is it the same as picking 1 apple out of 3 apples? It's the same, yeah? Look, there are 3 apples. I want to pick 2 apples. How many ways I can pick 2 apples? These 2 apples, these 2 apples, and these 2 apples, right? How many ways I can pick one apple?
3.
Look, every time I pick 2 apples, there's 1 apple, yeah? Alright? I pick these 2 apples, I have this 1 apple. I pick these 2 apples, I have this 1 apple. So does it make sense? CNK equals CN n minus k. Alright? Got it? Yes? Does it make sense?
Yeah.
How many ways if I want to pick 99 apples out of 100 apples? C 199.
100.
Yes, well done. How can we get it? Because this equals C 101. Picking 1 apples out of 100 apples. How many apples? How many ways can you pick 1 apple out of 100 apples? Huh?
100.
100, yeah? 100. Good job. Okay, so now today look. We need to, given a n and k, we want to return a list of the combination solution. Yeah, Eric?
Yeah.
How can we do it? How can we do it? Any thoughts?
If.
Yeah. So look, n. First of all, we know n, the candidate's apple. Okay, the apple is 1, 2, 3 till n, right? Yeah. Alright? Eric?
Yeah.
Look, these are the apples we need to pick. Yeah, we can pick. We can pick. Right?
I will pick.
So this, yeah, when we pick one, yeah, for each one we can pick. For each one, when we have less than k apples, we can choose pick or not pick. Am I right?
Yeah.
Does it make sense?
Yeah.
So we can do this recursively. So for each, we have a function pick. And then for these current apples, okay, we can go from the left to the right. For each apple, we choose pick or not pick. There are 2 solutions, right? Alright? Yes? Yeah, and when we have k apples, we have a solution. Am I right? Am I right, Eric?
Yeah.
Okay, so let's do it. Define, let's call it com, okay, com, n, k, what's missing?
Column.
Well done. So let's put it in the answer, okay, put it in the list, okay. So this answer variable is used to store the solutions there.
Yeah.
So that will be containing the C and K solutions. Okay. So now we can define a pick function. Pick
Yeah.
function. Eric, look. Listen. I'm going to test you later. Okay.
Yeah.
Pick. So currently we will have what? We will have left. Left means that we have the last apple we have picked is the left. Okay, we don't want to come back to again because look, picking 1, 2, 3 is the same as 3 to 1. Yeah, these are repeated, right? Am I right? Because the combination does not have orders, right? Picking 1, 2, 3 is the same as picking 3 to 1. So we want to avoid this kind of duplication. So we can specify that if we pick the last apple is 3, we don't want to come back to pick 1 and 2 again. Am I right? Does it make sense? Does it make sense? Yeah? So the left, and then we have a current solution. Okay, current solution. Look, Eric, if length of current, if now we are picking equal k, if we have finished, if we currently have k elements in the basket, let's say, in the basket, we have k apples in the basket. What should we do? We now find a solution, right? Then we do it. Answer dot append. Does it make sense? Append what?
Append the left.
Current. Come on. Current and return. Okay, we just return. We don't continue. Right? Then look. For. Okay, let's do it for apple. Okay, let's do it for apple. Right, Eric?
Yeah.
Let me do this left. Define it as last apple. Okay, last apple. Okay? Look, Eric.
Yeah.
You're so busy. What are you so busy with? Come on, Ryan is good. Ryan sits there listening, and you're so busy.
I am listening.
Okay, for apple
Yeah.
in range, last apple. We start from last apple, and we go to n plus 1, right? N plus 1 column.
Yeah.
And then we need to current basket. Current is current basket. Current dot let's make it basket, okay? So you know what it is.
Yeah.
Or maybe box, okay? You want to have a box with the apples. Okay, look. If the box contains k elements, we append the box to the solution, yeah? For apple, in range, last apple and n plus 1, the last apple will be n, right? Will be number n. Box dot append. Okay, let's pick this apple, okay? And then when we pick this apple, we need to try to pick the next apple. So we pick again. Pick what? Apple plus 1 box. Okay? And then this is the interesting part. When we pick this apple, we want to try not picking this apple. So box dot pop.
You take it out.
Yeah, look, box dot append. Currently we put this apple, right?
Yeah.
And then when we pick this apple, we try picking the next apple, right?
Yeah.
Otherwise, and then we also want to try without picking this apple. And then after this, we can just return pick, starting from pick the first apple, okay?
Yeah.
Pick the first apple, and the current basket is empty. We just put it here, right? Right?
Yeah.
And then return answer. Okay, look here, there's a problem because this. Remember last time we talked about when you append this is by reference, right? Because this box is a reference, it's an alias. So we want to make a copy here. So we can use the deep copy box here, right? Deep copy box. Or we can simply use this. We can simply do this. This is the same as box bracket, just a single column. Got it? This means that I make a deep copy of box, right? Does it make sense? Why we want to make a big a box? Otherwise, the content of the box is always changing because there's only one box, right? I want to when I have k apples in a box. What I want to do? I want to remember this solution and I make a copy of box and I put it in a solution. Does it make sense? Alright? And when we start picking the first apple, why here is empty? Can you tell me why this is empty? When we first pick it, we want to start picking the first apple with what? What's this? Empty what?
Empty bucket.
I know it's empty. What does it mean? What's the second parameter? I'm testing you if you listen that carefully, right?
The box.
Yes, that's the box. When we pick the first apple, we want to try pick it, but at the beginning we have empty box. Am I right? Am I right?
Yeah.
And I can pick the first apple, right? When I pick the first apple, I can pick the next apple. And when the box contains k apples, look, when the box contains k apples, what should we do? What should we do here? We say we know. Then we have apple. We have a solution of combination. Am I right?
Yeah.
Okay. Okay. So what's the term complexity? I'm just testing. What's the term complexity? Oh what? It's not n anymore. They say n and a k. What's the complexity?
K. Yeah.
Sorry?
O and K.
What's n and k? O c and k, right?
Yeah.
This is the combination because this solution is to pick k apples out of n. And then how many solutions are there? There's c and k, right?
Yeah.
So the term complexity is O, C, and k. Am I right? What's the space complexity?
O, K, and K. Yeah.
What's the space complexity?
C and K.
Yes, it's the same because we have c and k of solution. Put it in the answer, right? Does it make sense?
C.
And where's the recursion happening? Can you tell me where's the recursion?
What's a recursion?
Calling itself. Remember? Recursion. Where's the
Is that where the
yeah, and which part is calling itself?
box?
No. Box is a variable. Which method is calling itself?
Pick.
Pick. And where is the pick?
Pick.
Yeah, when we pick this apple, we want to pick the next apple, right?
Pick. Yeah.
Yeah, does it make sense?
Yeah.
Okay, I'm going to erase some of it, okay?
C.
Okay, wow. There's something here, and there's something here. Pick one.
I think.
You want to help write Eric?
I'll say well.
Yeah, I'm gonna help. What?
I think there's something about.
We want to pick this apple, but now after picking, we want to remove it from the box. No.
Pop.
Yes, pop. What kind of pop? This is pop.
Apple dot pop.
There's no apples. No.
Oh, box.
Box dot pop. Okay, well done. Ryan, you're paying attention. Okay, and what's this?
Needs to
Pick.
be a.
Pick one. Pick one. At the beginning, we want to pick
plus one.
no, one. Yeah, picking one apple and then with what?
Box.
What box? Can you write it? Yeah, empty array. Okay, empty list. This is the list. List in Python. List. We use it to store the contents. Store the apples in. It means there's no apple. Nothing in the box, right?
Nothing.
Yeah. And when we have 1, 2, what does it mean? We have the 1 and 2 box. What? Can you explain what's this? 1, 2. What's this? Can you tell me what's this?
That's already.
Huh? Array, yeah, array. And there are 2 elements, yeah?
Yeah.
And then the apple, first apple and second apple in the box. Got it?
Yeah.
Okay, that's it for today. Thank you.
Pew.
You need to say see you tomorrow.
See you tomorrow. Pew.
Okay, say bye-bye. Bye-bye.
Pew.
Bye-bye.
Pew.
Okay, that's it. Thank you for watching.
Pew.